omega E and V, you know that Vn was we estimated that before. The easy estimation gives you that if you have an n particle, and if the volume of the system is V, so the omega will be proportional to the Vn. But also, if you look at that, it will be proportional also. Yeah, so it will be function of, it will be can I write that? Yeah, it will be function of this. EV? No. Yes, EV.
Yes.
Even this equation can be used, and from the thermodynamic, just by simple thermodynamic equation, from here you can get some idea, because entropy is chi B ln omega. So you can get the pressure. I want to tell you that the PV still is NB car T still. And you can get also from this, only from that, you can get that 3 to N car BT, just. You know, because P is minus 1 the E 1 the V, and you can change that to the derivative of the entropy. So just using the partial derivative, you can derivative. You can change that to the run the S to run the E, and run the S to run the V, and that's I will ask you to do later. What maybe I will do. I want to tell you that even this rough this estimation gives you one more equation, like E is just with that. So I was not able to complete this today, but keep it like that. Keep it like that. So the goal is that finding the volume. Finding volume for 3n sphere, or n ball. If you can find the volume for that, I mean the volume of this equation, so you can get the omega. So omega so far is that, and it's proportional to the volume of 3n sphere. So this volume of 3n sphere, I mean, I need to find this integral. You know that R is radical 8mh square EV2 property. I need to find this integral. If I can find this volume, of course I told you that again that this is not the volume. This is the volume, but we need actually the surface. So I will relate the surface to the volume, but I told you again, I mentioned here that the Ln, at the level of the Ln, when n is going to infinity actually, because n is a very big number, so there is no big difference between the Ln of V and Ln of S. But we need to evaluate this integral. We need to evaluate this integral. So we need to evaluate the integral of dA 3n, yes, sigma nr square. I can't complete that because no more time, but yes, I want to tell you one thing. If you have an N1, the volume of the 3 sphere is that. is dx, dy, dz, x squared plus y squared plus z squared, 0 to r squared. I want you perform these three integration, triple integration, and you know what is the solution, will be 4 pi r squared. Yeah. If you have a surface instead of that, you needed to make this integral, dx, dy. But for, for dimension greater than the 3, we need other technique. That will be PR squared. I want to find that. And for one dimension, it will be just that, x between 0 to r. So that will be r. But what about the n dimension? So we needed to calculate this n dimension integral. One thing before to leave, I want to mention here that actually the volume and the area are related like that to each other, huh? See, there is a P and something number here, but just consider like that, cylinder, for example, huh? So the volume of the cylinder is PR squared L, and this PR squared is the area, yeah, and it is L playing the role of the height, yeah. So same thing here, huh? So I can write the differential of the volume if you consider the area multiplied to the, this is very similar to the height, and this is the area actually, and this is like the volume. So I will use this intuition to find the volume of the higher dimensional object, like n dimension. I will use that. But next lecture.